Let's go through some worded problems for Pythagoras' theorem. If you need a refresher, head back to a previous video where I'll take you through some simpler examples in more detail. Here's a reminder that the hypotenuse squared, that's the side opposite the right angle, is equal to the sum of the squares of the other two sides. So we've got 4 we're going to work through here. First advice, draw a picture if you can. These are all right angle triangle problems, so that's the picture that you're going to have at some point in time. So the longest side of a rectangle is 12 centimetres and its diagonal is 13 centimetres. So I recommend we draw a rectangle first. Doesn't have to be too accurate. So the longest side, so we've got to put the 12 centimetres somewhere. Let's put it on the longest side. And the diagonal, we're told, is 13 centimetres. So the diagonal, doesn't matter which side you go from, is 13. So let's label that. Now, rectangles have right-angled corners, so we could put that symbol in there, and we're being asked to find the length of the shorter side. So we would call that our x, or any unknown. You could put it on either side, the left or the right-hand side. If you have trouble seeing the triangle, feel free to extract it out and write it separately if you prefer. I'll just do that here for the first question. Now, which version of Pythagoras are we using? Do we have the hypotenuse value or not? Yes, we do. So let's use the version where the hypotenuse is on the right-hand side. My advice here is, so essentially we're going to be using a squared plus b squared is equal to h squared. Let the unknown side be the one that comes first. That'll make your rearranging much easier later on. Okay, so we've got x squared for the unknown side, our b squared is the 12 side, and our hypotenuse is the side opposite the right angle. So we've got 13 squared, not cubed. So we have to rearrange that, working them out. You can rearrange first or work out. So 12 squared is 144 and 13 squared is 169. You then subtract 144 from 169, which would give you 25. And then square rooting 25. That is a perfect number, so you could jump straight to the answer there. But we've got 5. But what units? It's 5 centimetres. So have we found the length of the shorter side? Yes, we have. But there was a part B here, the area of the rectangle. So area of a rectangle, do you remember what it is? Length times by width. That's how I do my length, my L's. Length is 12 centimetres and our width is 5. That's what we found in part A. 12 times by 5 is 60. What's the units for that though? Centimetres squared. So there's the area of our rectangle. Let's do another one. A rhombus this time has diagonals of length 8 and 10 centimetres. A rhombus. Here's a word, scrombus, which some students that I taught in the past came up with. A rhombus is like a square, but pushed over a bit. Square, rhombus, scrombus. Whereas a rectangle and a parallelogram have more in common. So a parallelogram's a rectangle pushed over. So a rhombus has sides all of the same length. So I'll try and approximately draw that. So that would be a rhombus. And now the diagonals, so from corner to corner, 8 and 10. Which one's which? The short one would be 8, long one 10. Now here's a fact about a rhombus that you need to know, that the diagonals bisect at right angles. So the two key words up there are the right angles, means that intersection point, we can put a right angle symbol in there now. And they bisect, which means they cut each other in half. So this side of the rhombus there will be the same length as here, and that's the shorter side. So we've got a 4 centimetres there and a 4 on the other. And the long one, the 10, I'll do a double dash for that. If they are bisecting, they are 5 centimetres. I'm just going to extract out a triangle here because I think I've drawn my picture a bit small. So we've got a right angle triangle. I'll use the top one. We've got 4 centimetres on one side, 5 centimetres on the other, and we're asked to find the length of its sides, which are of course those exterior sides here. So we'll let that be x. Now, is x the hypotenuse or not? Yes, it is. It's opposite the right angle. So we'll use the version where the hypotenuse is on the left-hand side. X squared is equal to 4 squared plus 5 squared, the square of the other sides there. Working that out, we've got 16 plus 25, and x, therefore, x squared is equal to 41. Undoing the square, is a square root on the right hand side, so x is equal to 41. What units? Centimetres. And you can leave it at square root of 41, or you can work that out as a number with a decimal. So making sure you've drawn the picture, labelling it, sometimes writing out a separate triangle might be easier to work things out. This question here, Bjorn suspects that the corner A of a tennis court is not a right angle. So with measuring tape, he finds that AB is 3.72 metres, BC is 4.56 metres, and AC is 2.64 metres. Is his suspicion correct? The idea of solving this one is often what we call the converse of Pythagoras' theorem, which is if the longest side squared therefore must be equal to, for a triangle to be right angled, the sum of the squares of the other two. If they're not equal, what does that tell you about the triangle? It's not right angled. So to test Pythagoras' theorem, take those two facts separately and see if they equal each other. So let's take the hypotenuse side then, which is BC. Square that number, 4.56 squared, is approximately equal to, now it's 20.7936, but let's round that. Let's go 0.8. Now when you do approximately equal to, you can do that as equals with a dot at the top of the bottom, or you can do it wavy, which is, I'll just write that here, approximately equal to. You might prefer one or the other, or you can interchange them. So 20.8 centimetres to 1 decimal place, or what we call 3 significant figures there. And let's test it with the other side. So we're going to do AC squared plus AB squared. What do we have for that? AC is 2.64 squared, adding on 3.72 squared. When you work them out, again, it's 20.81. So 20.81 is exact, or if we round, we've got 20.8. Now, some of you might say, well, they're not absolutely exactly the same. So no, his suspicion is correct. They're not right angled. However, have a think about this in practical terms. You know, if you've ever done any building or outside measuring yourself, it is very hard to get exactly precise. So to 3 significant figures or 1 decimal place, that's actually pretty good. And so this is a worded question, so you must answer with words in a sentence. Is Bjorn's suspicion correct? I'm actually going to say no. So no, his suspicion is not correct due to the limitations or the accuracy available when measuring. So let's write something like that. So have we answered the question, is his suspicion correct or not, and give a reason? That's often really important in these worded problems to show your knowledge and understanding there. And last one here, Kimmy leaves point A and heads east for 5 kilometres. He then heads south for 6 kilometres. How far is he now from point A? Whenever you see a question here with a north, south, east and west, it can be quite handy to draw a compass. I think it's called a compass rose. Never eat soggy Weet-Bix is how I learnt it, or news are the letters, but that's not in order there. All right, so put a point for where the person is, Kimmy, or we'll call that point A. What's the first thing they do? They go east, so off to the right. On my screen, that's probably that way. For how long? 5 kilometres. And then south for 6 kilometres. Make that slightly longer. And then how far is he from point A? So he's down the bottom here now, and so that's, as the crow flies, as we say, on that diagonal line, that's the hypotenuse. Well, we've got a right-angled triangle here because he walked due east and due south, and we're going to solve for this unknown side here. So once you've got your picture, I'm sure you'll agree, applying Pythagoras' theorem is quite easy from that point. So working this out here, 5 squared is 25, 6 squared is 36, and that comes to 61, undoing the square there, so the square root of 61. Let's actually work that out. It comes out to approximately, so I'm going to put the dots either side of my equals, 7.81. What units is that? Kilometres. So how far is he from point A? Kimmy is, so answer in a sentence, is 7.81 kilometres from A. So those sentence answers are really important in these worded questions. Okay, time to do some questions. Thanks for listening. Subscribe to the channel and share this with somebody that you think might need to know this as well. Thank you.